Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good morning. So today we will continue on next chapter, which is the first part being covered by Dr. Hafiz. So I'm covering on power quality and also facts. First and foremost, we have to know the activity of power quality, the incidents, the phenomenon, such as voltage sags or voltage dip, very short interruptions, long interruptions, voltage spike, voltage swell, harmonic distortions, voltage fluctuations, noise, and voltage unbalance. So, under the power quality regulations, what happens? These are the signal that happens, okay, when such as sag, there are sudden drop in the amplitudes of the signal of the inputs outputs. So, sometimes voltage dips, voltage swells, okay. Transients is a temporary phenomena that happens in our power system under voltages, harmonics, okay. So what's the problems, okay? We can refer CBEMA curve. So according to the standards, we can identify the minimum withstanding capability of computer equipments to voltage sags or micro interruptions and over voltages. Okay, we can identify the problems such as transients. It can be impulsive transients due to switching, but it is temporary, or it can be oscillatory transients where it can be high frequency, low frequency. Okay, next is long durations voltage variations. So under this category of problems, there are over voltages, under voltages, and sustain, meaning it's continuously interrupt the system. Therefore we call it long duration voltage variations. Next, under short duration voltage variations, we have interruptions, voltage sag or voltage swell. So it happens in, you can say it very short, meaning is maybe 1 seconds, less than that. But it will also affected our system, especially on the sensitive equipments. Okay. Next is voltage imbalance and waveform distortion. So in these types of waveform distortions, we have type of DC offsets. Okay, harmonics. Okay, you know harmonics, interharmonics, notching, noise. Next is flicker. Normally flicker can be due to sudden breakdown or a high, we call it impulse switching current, or it can be from the consumer end devices. How we want to evaluate power quality problem? First, we need to identify what is the problem category. Is it flicker? Is it voltage? Is it transient? Is it harmonics? And then we characterizing each of these problem. Is it impacting our equipment? It can be a breakdown. Okay, maybe our molding equipment breakdown due to these harmonics, such as I have been assigned a project in Johor, Port Johor, Tanjung Pelepas Port, whereas they have some downs in the system due to voltage sags. They do not know where is the origins, the causes, but they know the characteristics. So we do a study using ETAP to identify. When we identify, what one of the solutions is using BESS. Okay, and then we identify range of the solution. What is the equipment design? Is it matching with transmissions designed by, which is in Malaysia we call it Tenaga Nasional Berhad (TNB), and mesh with the end user of customer interface, right? Distribution system, not only transmission system, we do have to know about distribution system, the end user. All right. Next, we evaluate the solutions. We do a procedural analysis, evaluate the technical alternative that relates to the power quality, and last but not least, the optimal solutions. Is it using UPS, surge protector, STATCOM, DVR, STS, BESS, so on and so forth. We need to know the source of power quality sources. Okay, power quality have three main sources that origin this issue. Okay, it can be from the utility, meaning from the supplier. Okay, the utility supply, meaning the issue from them, or it can be internal, inside our building, inside our facilities, or it can be due to power electronic equipment that currently used. Okay, from the utility sources, it can be lightning. It's a natural phenomenon. We can control it. Of course, in Malaysia, plenty lightning activities. Okay, maybe utility sources they have a power correction equipment such as static wall capacitor, a power bank, so it will contribute on the power quality also. Next is fault. Something is very unintended breakdown. Okay, switching, of course we have to switching, of course when you do correction. Okay, correction maintenance or preventive maintenance, routine maintenance. All right. Next is coming from our own system, which is internal sources due to individual loads. Even our ballast contribute on power quality issue. Maybe nowadays most of our lighting systems don't use ballast anymore. We use LED. Okay, arc welders, medical equipment. Other than that, power electronic, most of our AC system, air conditioning system, we have the applied with VFD, variable frequency drive, where we focus on energy efficiency. But this type of drive contribute on the power quality issue. All right. Other than that, charges. We have EV chargers now. Even all of our daily drive, like our phone or computers, using chargers. Smart grids, even though it's so smart, but it could also contribute to a power quality issue. It's not something that we have to avoid, but we have to manage it. Dimming equipments. So nowadays, like a Kinect system, we have a dimming system where it can use maybe a fractions of energy when there are no what you say users in each room, in each area. Microgrids or large motors, and last but not least is UPS. What are the facilities that affected by power quality? First, the most important thing we have to know about the cause. Okay, because in certain facilities, the cause of each incident due to power quality issue, it may impact the operational cost, such as pharmaceuticals. They rely on a good supply, a quality supply by the utilities. Next is semiconductor. Whereas in Malaysia, there are plenty of semiconductors throughout from north to south. So each semiconductor plant rely on a good supply. Therefore, they also have their own, we call it gensets, to prepare. Next is data centers. So Malaysia also, we are exploding with new data centers. So this is type of facilities that affected high cost. In terms of median cost, median that affected is automotive manufacturing. Malaysia, we have Proton, we have Produa, we have BYD. We have what other than that? Okay, glass plant. We have in Naka also we have Xini glass. We produce glasses, plastics, textile, and chemical in low cost, especially in offices, home lighting. So the cost is very low. And again, you said the source of, but the cost is very low. The affected is very low in terms of smart grid, micro grid, and also and devices. We have to learn about voltage sex. Voltage sex, or we call it voltage dip, meaning that is the reduction in voltage. It can be lasting from 1 cycle or 2 seconds or milliseconds or 100 milliseconds. So according to the severity of each incident, that is voltage sag. Voltage sag causes by disturbance, okay, non-zero independent. So it increase the current in the voltage, okay. But you know that these reduction are small enough that it can be within the voltage tolerance, maybe plus 10 minus 6. Therefore, that it can be maintained. Normally, this phenomena origin from the large increase of in current, especially when we have lightning, we have fault like excavations, okay, and also increase in system impedance. Other than that, how we can mitigate this situation? We can use dynamic voltage restorer, active series compensator, StatCom, UPS. We can use BAS, battery storage energy supply, or ferro-resonant transformer, flywheel, motor generator set, or static VAR compensator.